So, hello everyone. Good afternoon. So, we are here with our revision lecture number 2 of electrostatic. So, today we are going to deal with the rest of the topics that we have left in the first lecture, and then we will see the next topics, okay, that we are going to learn. Okay. So, this is the day number 2 of this revision. Now, the electric potential that what we have to cover for today is electric potential and its calculation for a point charge, relation between electric field and electric potential for a continuous charge distribution. How are you? Are you fine? Good afternoon. So the revision that we are going to do today is for the electric potential and its calculation for a point charge, relation between electric field and electric potential for a continuous charge distribution, in which we mostly cover the spherical one, okay, the hollow sphere and solid sphere. Then electric potential due to electric dipole, and we will place the dipole in an external electric field, and then we will see the torque and the potential energy for that electric dipole. Okay, and obviously some PYQs we are also going to deal. Electric potential energy of a system of point charges, so that is also we are going to see. Then electric dipole in an electrostatic field and electrostatics of conductor. Okay, so that is all we are facing today. Hello Sangeeta, how are you? Good afternoon. Okay, so make sure the screen is visible to you and I'm audible to you. Got it? So Sangeeta and yeah, good afternoon Odin. How are you? Is the screen is visible to you and I'm audible to you? Both of you? Okay, okay. So everything is clear to you now what we are going to do today. In the previous lecture, we have left with some topics. So firstly, we are going to cover them and then we will move forward with this. Yeah. Good afternoon, Sangeeta. Okay. So the first topic that we have left for the previous lecture is electric field due to the continuous charge distribution. Okay. And you do not have to worry about this. Okay. Conducting solid sphere, hollow sphere, or non-conducting hollow sphere. For three of them, we have a single formula that will be followed by all of them. Because if you talk about, let's say, if you talk about a conducting sphere, hollow, so all the charge, we know that if any material is conducting, the charge will be come out on its surface. But if it is a solid conducting sphere, so what happens? If you put the charge at the center, it will come at the surface for solid and hollow both. But in case of non-conducting sphere, we know that in non-conducting sphere, the charge will not conduct. So it will remain wherever you will give. So for hollow sphere, where is the possibility that you can give the charge on the surface? So it will remain on the surface. So that is why the formula for solid, hollow and solid conducting sphere and hollow non-conducting sphere is same. Okay, so I have three possibility here. At inside a point, if the point lies inside the sphere, on the surface, and at outside point. Hello Anand, how are you? So we are going to see that point outside this. So there is a sphere, and if a point lies outside of it, so this sphere will be treated as a point mass. Okay, and we know that from a point mass, if this is a point mass, or point charge, you can say point charge. I'm confused with the gravitation part. Huh? It's okay. So you can consider this hollow sphere or solid sphere conducting and non-conducting hollow sphere to be a point charge if the point lies outside of it. The electric field is given by kq upon r square. Okay, where q is the charge given to the sphere and k has a value of 1 upon 4 pi epsilon naught, which also results in 9 into 10 raised to the power 9 and rest the unit. Okay, now on the surface, if you talk about on the surface, it will become E is equals to kq. If you put the value of r is capital R, so it will become this. Okay, but let me write it here, kq over capital R square, where r is the radius of the sphere. Now we measure all the distances from the center of the sphere. Now if a point lies inside the sphere, so we know that inside there is no charge. In case of solid sphere, of conducting solid sphere and hollow conducting sphere, there is no charge inside it. So if there is no charge, so there will be no electric field. So at inside point, the electric field will be 0 because there is no charge enclosed by it. Hello Manu, how are you? Got it? So in the three cases we have discussed, so for a point which is outside the sphere, you will consider that sphere to be a point mass, and the formula that we are going to use is kq over small r square. Now on the surface, if you talk about, so on the surface it is kq upon r square. Got it? Now at point inside point will cover no charge. So there is no charge inside the sphere. So that is why the electric field is also 0. Got it? Now, I hope you are clear with this. It's just a revision, so that is why we are not deriving anything, because you guys have just given your examination, so everything is in your mind, the derivation part. I'm just here to revise you, to give you the concept behind that, not about the fact. Okay. And by the way, how's your examination? How was your exam? You just gave your pre-board, na? I think. How was your examination? So, electric field due to continuous charge distribution. Mein, next topic we have non-conducting solid sphere. Okay. So, Odin is saying that exams was good, and Sangeeta is saying not so good. Hello, Pooja. How are you? Okay, it is not. I will tell you one thing. The exam is not to judge you. Okay, that you are. If someone is getting good marks, he is good, he will be doing good for the entire life. That is not good. Exam is to examine yourself. It is for you, not for us. It is for you only, so that you can learn from yourself that where did you have mistakes. Okay, where you have focus more. Like Sangeeta was saying, I'm sorry if you are not comfortable that I'm taking your name, but the fact is that the exam is to decide that which topic you have to focus more. Okay, so if your electrostatic part is not good, so focus more on electrostatic. Okay, so do not get like uh, disappoint. Okay, thank you Sangeeta. So do not get disappointed with your results. Okay, try to learn and do that thing, so that that particular result that you have got now will not repeat in the next examination. So that should be your aim. And if you are getting the same result, that is why you are not improving yourself. You know? You are the same Sangeeta, you are the same Manu, you are the same Udin. You have not been improved. Okay. So try to improve yourself. Got it? Now, back to the topic. Electric field due to continuous charge distribution. इसमें नॉन कंडक्टिंग सॉलिड स्फीयर इज द डिफरेंट वन. व्हाई? बिकॉज नॉन कंडक्टिंग सॉलिड स्फीयर क्या करता है? व्हाट डज इट डू? if you given the charge to it, the charge will lies inside of it. For in case of solid sphere but conducting, the charge will conduct and travel to the surface of it. But in case of non-conducting, we know that it is non-conducting. By its name we can say that charge cannot be conduct here from the center to the periphery of it. So charge will remain inside of it. Okay. And so for that, outside point, no worry, because outside point you can consider this to be a point mass. So do not worry about it. So it is kq by r square. Okay. On the surface, no, do not have to worry. Surface also kq by r square. R is the radius. Now inside, so we know that at inside of non-conducting solid sphere, it is k capital Q small r divided by r cube. Hello Swati, how are you? So in the inside point, we know that this electric field varies linearly, which means at inside point now the electric field not be zero. Got it? Okay. So if you try to draw the graph of it, it will vary linearly up to radius, and for that it will vary hyperbolically. This is E and this is small r. Okay. And in case of the previous one, the electric field versus r will be drawn by, like for inside it is 0, so it will be 0 for what point? Up to surface. At surface it has some value and then it will decrease at hyperbolic. So this is the variation. This is not including. Okay, only this one is included. Okay, this is r, this is C. So try to remember with the graph. Dekho, you received a question from that in the latest JEE Mains exam. So graphical variation of electric field due to uniformly charged insulating solid sphere. Insulating means non-conducting, which cannot conduct electricity. That is an insulator. Solid sphere of radius r, where the distance r from the center O is represented by. Now, every one of you, I can guarantee that every one of you can answer it. So try to answer in the chat box. What is the option? What is the correct option of it? Option 1, 2, 3, or 4. Hurry up. Every one of you. I want the answer from every one of you that have joined. Come on, Sangeeta. Manu. 4. Okay. Wouldn't you have typed 14? 14, I think it's not the option. Okay, 4. So maximum of you are saying 4. But in the previous concept that we have taught, this is the non-conducting solid sphere. At inside point, the intensity, electric field intensity varies linearly. So at center, R is equals to 0. So electric field will be 0, which means the graph will start from 0 and varies linearly up to R, and then will start decreasing with the relation E is equals to KQ upon R square. So in fourth option, it is a constant value. Okay. The E must not be constant. E will not be constant for the inside value. E will vary linearly. So you have to find out the option contained in this line. Now tell me the answer. Okay. So option 1 is the correct option. Sangeeta, option 1 is the correct option. Every one of you. Okay. So this is a learning. You have just answer it with the hurry up that we have to answer it, है ना? And this the silly mistake you have did. and 4 marks you will lose. So try to avoid these mistakes. Okay. Now, electric field due to continuous charge distribution. Infinitely long wire. So we know that for infinitely long wire, what we can consider, we will consider a Gaussian surface so that the electric field. Now, what should be the electric field? How it is represented by electric line? So it will be perpendicular to the line charge like this, and it will be in both direction. Okay. Got it? Now, this is the infinitely long wire. So we will consider a Gaussian surface to it and try to calculate the electric field intensity. So if you see that this surface, the electric fields are parallel to this surface, but the area vector is perpendicular. We know that the Gauss law will say that electric flux is equals to the charge enclosed divided by epsilon naught. And this is given by E into dA. And this area is of the Gaussian surface. So always try to remember. It is for that surface area which has enclosed the charge. Got it? And that should be the Gaussian surface that we have assumed. Got it? So E dot dA is equals to Q enclosed upon epsilon naught. We know that Q enclosed, this is the linear charge density, lambda is given. So lambda is nothing but charge per unit length. Any charge you can, any length you have taken, we have taken it for length L, let's say. The length of the cylinder that we have assumed is L. So charge enclosed by this cylinder will be lambda into small l. Okay. Now area of this. So here 3 areas are in contact. First is this one, top area, base area, and this curved area. So if you will see, the base area will also, for a 3D body, the area vector will lies outside the body. Okay, always remember. And the electric field is in this direction. So they have 90-degree angle here. They have also 90-degree angle. So we have E dA cos 90 because dot product open with E dA cos theta plus E dA cos 90 plus. Here if you will see, the area vector for this particular curved surface will be outside the surface, and this is along E vector. So here in this case it will be E into dA cos 0. This will become 0. E dA cos 0 will become E into A, and this is lambda small l divided by epsilon naught. Area, you have to take the curved area only, which is E into 2 pi r into length to lambda l divided by epsilon naught. Lambda will cancel out. So E you will have as lambda upon 2 pi r epsilon naught. Got it? If this is the negative charge, so lambda will be minus. So E will be minus lambda 2 pi r epsilon. Simple. Got it? Now, the conducting infinitely long sheet. So sheet के लिए the same procedure we are going to follow. We will take a Gaussian pile box. It will say it, or you can say it a cylinder also with a short length. Okay. Then again, here are 3 area in the contact. If you will see, this is the Gaussian cylinder that we have selected, and that is a portion of this sheet which come inside this. Positive, positive. Okay. So here in the case of sheet, you have to take sigma. Sigma is the areal charge density. Areal charge density, which is given by sigma into charge per unit area. Okay. So this much area has enclosed the charge, and the area is same as the base area or top area of the cylinder. Let's say it is A. Got it? So same E into dA, because if you say for this surface is contacted in the curved one, this charge enclosed with the contact of this curved surface, and curved surface has area vector perpendicular to it or radially to it. But we will see here the electric field is in this direction, and so the angle between electric field and the area vector is 90 degree. So now this time this curved surface will play no role, only the base area will be there. So same amount of electric field will be here and same amount of electric field will be here. So you can say that 2 times of electric field into the base area multiplied by Q enclosed. So we can say it that sigma into that particular area divided by epsilon naught. How simple is this? Now area and area you will cancel out. So electric field you will have as sigma upon 2 epsilon naught. Okay, got it? Now, if the sheet is non-conducting, look, there are many cases possible in this. If the sheet is thick, then there will be a case. If the sheet is thickness is also there, but we have considered very thin sheet. The thickness we are not considering. So in case of conducting, if there is the thickness in the sheet, it will play no role. The same intensity, electric field intensity you will have for thin and thick conducting sheet. But if you talk about the non-conducting side and you have given charge to this surface, so now you know that this sheet is non-conducting. So this charge will not travel in this side. So only if you make a pile box, which is the Gaussian surface, which has covered this surface of this sheet, only this side has charge, but on the opposite side we do not have any charge. Got it? So if you will see, only if you given to the front surface, the charge is given to the front surface, only the front surface has the charge, not the back surface. Got it? Only this side you have charge, not on the other side. So the electric field will be sigma upon epsilon naught. Okay, because this is for the complete sheet and this is for this sheet only this side we have charges. So electric field will be sigma upon epsilon naught. Got it? Now, and one thing more I want to discuss with you. If you considering it in a thickness, this is a thick sheet you have taken. So what will happen here? If this is a non-conducting sheet, so charge will be inside of it. So you need 3 situations there. First, you have to consider when the pile box or the Gaussian surface you have taken inside of it. Okay, then here now it will become a 3D body. So instead of using sigma, we cannot use sigma here. Sigma is the areal charge density. This is charge per unit area. But here you will see the charge is in 3D shape. This is a cuboid type of thing. So you need to consider rho, which is volumetric charge density. Got it? So this thing I want to tell you now. Electric field due to dipole. So we know the dipole. Dipole is the arrangement of 2 charges, same in magnitude, opposite in nature, separated by a distance. Let's say we have taken it 12. So this arrangement is termed as what? this arrangement is called electric dipole. Okay, di means two, poles means you can relate the pole here with charges. Okay, and this is the center of it. So we know that electric field always directed from positive to negative. So here the dipole moment, we know that it has a dipole moment which is given by P, and it is a vector quantity. So it is given by Q into 2L vector. Okay. Now in magnitude, you can say that it is Q2L. Charge multiply by the, any one of charge you will take, multiply by the separation between them. This is the dipole moment. Dipole moment. Okay. So everyone is getting na what I'm trying to say you. Okay. Do not try to sleep in between the lecture. This is for you guys, huh? So dipole moment is P into Q into 2L. P is equals to Q into 2L. Okay. Dipole moment has the opposite direction from electric field. So it is from positive to negative, but in chemistry you will see it is from negative to positive. So that is a different scenario. We will focus on physics. Okay. Now, in this axial position, if this is the axial position along the axis of it, if the point is lied along the axis, this is termed as the axial position of the dipole. You need to calculate the electric field at point P. So it will be 2kp vector divided by r cube, and it is for short dipole. Short dipole. Okay. Short dipole के लिए what is the condition? If from the center of this dipole, this point P is r distance. So if r is very, very greater than L, so you need to apply this formula. So most of the time, in most of the numerical, you will see this formula will be valid. Okay. So P vector here is the dipole moment vector. Okay. So in this axial position, electric field and dipole moment are in same direction. Same direction. So this is an important point. So for axial position, this electric field vector and dipole moment vector will be in same direction. Okay. Now, in equatorial position, so this is the dipole we have. This is the center. So equatorial position is to be the position perpendicular to the dipole and exactly at the perpendicular bisector of it. So if you drop the perpendicular from this point, it will divide this line joining these two charges into half part. Okay. So this line is also termed as the perpendicular bisector, and you will see different name of it: equatorial position, perpendicular bisector position. Okay. And it is also heads on position, you can also see. Okay. So at this position, we need to find out the electric field. So it is from the equation, you can say E equatorial is minus of Kp upon R cube. And it is if the dipole from positive to negative in this direction. So electric field, this is the dipole moment vector. The electric field will be in the opposite direction. Okay. Now, in this situation, the electric field vector and dipole moment vector are in opposite direction. This is the important point. So on equatorial position, these both vectors, E vector and P vector, are in opposite direction, and magnitude is given by Kp vector over R cube, and it is the half of the axial position. So E axial is half of the, you can say it is, if you divide this by 2, you will get E equatorial. So E axial equals to 2 times of E equatorial in magnitude. Okay. Now we will take it at any general point. This is the dipole minus q plus q, and there is a point here which is not at the perpendicular bisector and not at the axial position. It is at a angle theta from the center of dipole. This is point P. For that particular point, the net electric field is given by Kp over r cube. Kp over r cube square root of 1 plus 3 cos square theta. Okay. Now, if we put theta is equals to 0, theta is equals to 0, it means that point P on the axial position. So theta is equals to 0 will become cos 0, 1 plus cos 0 into 1. So 1 plus 3 into 1 become 4, and square root of 4 will become 2. So it will become 2 kp over r cube. If you put theta is equals to 90 degree, it is on the perpendicular bisector. 3 into cos 90 will become 0. It is square root of 1 kp over r cube, and direction we know already. Okay. Now, this is the question, latest question of JEE Main 2023. 2-point charges minus q and plus q are placed at a distance of L, which means it forming a dipole. Minus q and plus q, two charges, same magnitude, opposite in sign, separated by some distance. So which means this is a electric dipole. So the magnitude of electric field intensity at a distance r varies as. Okay. So here we know that in the previous case, if you will see, in most of the cases, in the axial position and equatorial position and at the general position, the electric field varies as r cube. 1 upon r cube, you will see 1 upon r cube. So if you remember the three formula or two formula only, the axial and perpendicular, so you will see that the electric field varies as 1 by r cube, or capital R is given in this. So 1 by capital R cube. So option 1 is the correct option. How simple is this? You save so much of your time by just remembering that particular formula. Okay, you don't need to derive here, you don't need to apply any concept here. Okay, yeah, obviously you have to apply the concept, but look how much time you will save. You will solve this question within fraction of second, and that time you will apply for the question that include a derivation or numerical values. So formula, learning concept and formula is a very important thing. It will save your time. Now, we will deal with electric potential and its calculation for a point charge. So electric potential and its calculation for point charge. So what is an electric potential? Actually, the electric potential is not defined. Only the potential difference is defined. Okay? We do not know the exact potential of anyone. Look, if Swati and Manu, I will take example of Swati and Sangeeta. So do we know the actual potential of Sangeeta or Swati? Maybe in future we are predicted that Swati will become an engineer from that particular IIT. Or okay. But what if that Swati will become a businessman or an IAS officer? So we do not say about the exact potential of anyone. So how can we say it for a point charge? No, we cannot say. Only we will take the references. Okay. Like in same scenario, that particular student had performed this way, so Swati can be performed with this. So that we can take as a reference. Okay. If the height of Sangeeta is larger than Swati, so we can take that Sangeeta is taller than Swati. But if you talk about the exact, you have to take the reference from ground. You have to measure your height from the ground. You know? So that is why the electric potential is not defined, only the potential difference is defined. Delta V is defined. Okay. But in delta V, it is a VA minus VB, let's say. So we will take the initial point to be infinity, and V at infinity we would consider 0. So that is why we can say that if the potential at infinity is 0 and we have a test charge, okay, and we bring it to a point A from infinity, so what is the potential difference? We can say that VA minus V infinity. But we will assume that we have assumed that at infinity the potential difference is 0. So V infinity is 0. Then we can say VA is the actual potential of this charge Q. Okay. So try remember this concept. The exact potential difference, the exact potential is not defined, only the potential difference is defined. And for our references, we will take the potential at infinity to be 0. Okay. Now, what is the electric potential then? The electric potential is nothing but the work done that you have did to bring that point mass. Oh, sorry. I am teaching a topic gravitation in 11th class. So that is why a point mass and point charge sound similar. So try to forgive me for this, yeah. Okay. So electric potential is nothing but the work done that we have did to bring a point charge from infinity to a particular point. Okay. Let's say this point is A, and we have bring a point charge or test charge Q naught from infinity to this point. So infinity से किसी चार्ज को ला रहे हैं किसी पर्टिकुलर पॉइंट पर, सो वी हैव टू पुट सम वर्क ऑन ना, वी हैव टू डू सम वर्क. ऐसा तो नहीं है कि ऑटोमेटिकली ये खुद से ही आ जाएगा चल करके. वी हैव टू डू सम वर्क, एंड दैट वर्क डन per unit charge is defined as electric potential. Potential is just related to the सामर्थ्य, हिंदी में से बोलते हैं सामर्थ्य, the ability to do work, that is potential. Okay, how we define the energy? Energy is the ability to do work. Okay, or capacity to do work, how much work I can do depends on my potential energy, depends on my energy. And the rate of work done is power. How fastly I am doing the work, that is my power. Okay, so for a point charge, so potential is defined as, actually the potential difference is defined as the work done by external force, or let me write it as work done by external force infinity to point A divided by that particular value of charge. Okay, Q naught. But there is one condition, and very important condition, so that the kinetic energy through the entire journey, kinetic energy will remain 0, which means we are taking this point charge very slowly to the point A. Infinitesimally slow this process will be, so that it will not accelerate, because if it is accelerating, the entire system will change, the entire balance of energy will disturb, and we cannot say that this is the exact potential of this particular charge. Got it? Because if there is kinetic energy, some of the energy will be gone to the kinetic energy, and some of will be remaining in the potential energy. So that potential energy is not the exact one. So we'll keep this in mind, that kinetic energy of that particular point charge will be 0. Got it? During the entire process. So here delta V is equals to work done by external, and here we are not going to provide any external. We are applying external force, but against which? Against the electric field force. This point A is an electric field of any charge, any bigger charge, and we are bringing this charge particle to the field of this charge particle. So there is constantly a force applied on it if there are same charges, which is F electric. So we have done work against this force, okay, and which is exactly equals to F external. So if we replace it by F because we do not know the value of this, but we know the value of this F electric, which is given by Q into E. Okay. So, but if you will see, the displacement is in this direction and the force is in this direction, the F electric. So the angle will be 180 degree, which means work done is F dot D. It is FD cos of 180. Cos 180 will become negative. So it is negative of work done by electric force. So we will replace it by negative of work done by electric force infinity to A divided by Q naught. This is the actual definition of the potential difference. So for point charge, if you apply this formula to bring that point charge, so this delta V will become KQ upon R. Okay, and you will take V infinity as 0. So you can tell us about the exact potential of this point charge will be KQ upon small r. Potential is a scalar quantity and you need to put the charge with the value and sign also. So if in a question it is said that -2 coulomb charge is there, so you need to, for calculation of the potential, you need to put Q as -2. Okay, got it? So for point charge, it is given by KQ upon R. Now, relation between electric field and electric potential. So I do not need to do the derivation, complete derivation, although I will give you the idea. So this is the uniform electric field we have. On non-uniform you will take. And this is point A and this is point B. The distance between them is R. So what we have did, we have displaced this charge from point B to dr position. So the displacement is r plus dr completely from A to this point. Okay, there is a constant, there is a force which is F electric field QE is acting on this. So we have to work, we have to do the work against this. Okay, so finally the relation that we will get is nothing but, you can see that delta V is nothing but the work done minus of work done by electric force divided by charge. Okay, if the electric field is not constant, so we will take integration of the force into dr displacement. This is electric force. So from that value we will derive that this minus dV, the potential will also be, potential difference will also be small. So the minus dV is equals to, or you can say dV is equals to minus E vector dot dr vector. It's a very important relation. Try to just keep in your mind dV is equals to minus E dot dr, because it will going to resolve your problems with the continuous charge distribution. Okay, so dV here you can open this expression also, minus E, the magnitude you will take E dr cos theta. Okay, got it? From this expression you will see, if you write this dV as V2 minus V1, so you will see that this difference V2 minus V1 is negative minus E dot dr. If the difference between two quantity is negative, let's say this is number 8 and this is a number 12. So when is the possibility that the difference will be negative? When you 8 minus 12, okay, which means this V1 is greater than this V2. V1 is the initial position and V2 is the final position. So which means that initial potential V1 is greater than V2. So we can say that moving in the direction of electric field, the value of electric potential will decrease. Okay, so this is very important line. Moving in the direction of electric field, the potential will decrease. Very important line and keep remember. Okay. Okay. So now the electric potential due to continuous charge distribution, we have just seen the electric field expression for continuous charge distribution. So if you need to derive it now, okay, try to do one trick. That trick is nothing but dV is equals to minus E dot dr. Okay, put the expression of E for that particular shape that has been given in the question and integrate it. Okay, and you will find the same expression that is given here. Okay. So this one single relation can give you multiples of the expression that you need. Okay. Now the same story will be here for outside point. If if this is a conducting solid sphere, hollow sphere, or non-conducting hollow sphere. So the same scenario we will have, only difference is that in the expression. So what do we have? Now at outside point, if you talk, it is kq upon r, because if the point is outside, you will treat this sphere as a point mass, and for point and mass, what is the potential? We have already talked about it. It is kq upon r, and r is the distance from the center. Got it? At inside point, we know that at inside point electric field is 0. If this is the relation, dV is equals to E dot dr, okay, and E is 0, which means dV is equals to 0. Okay, dV is equals to 0 means V1 is equals to V2, which means the potential is not changing inside the point. It is a constant quantity. And how much value can the potential will change? Potential will change up to the surface. This is point P, let's say. This is the distance R between them. This R can be minimum to this point up to surface. Inside it will decrease. But we know that at inside point, the potential remain constant. And for outside, it is given by KQ by R. Got it? So the maximum value it can have at the surface. And if you just focus on this point, which is just inside the sphere, the potential will be same as the surface, because now it is not decreasing or not increasing. Okay. So it is kq upon capital R, which is the radius of the sphere, and it will remain constant throughout any point. At center also, it is kq upon R. Got it? Now, for non-conducting solid sphere. So although there has been question that has been asked, but not so much. So at outside point, V outside, if I talk about, same scenario will have to follow kq upon R. Okay, because if it is non-conducting also and solid also. But what about the point outside? You will take it as a point charge, and for point charge, the expression will be same, kq upon r. Now, on the surface, V surface is equals to kq upon r. You put, you have to focus. This is the small r, this is capital R. This is the radius of the sphere, because we have to measure the distances from center of the sphere. So if the point is at surface, the distance will be radius. For point inside, this V inside will be kq upon 2r cube into 3r square minus r square. So this is a heavy expression. Okay, you can learn it, no problem. I believed in you that you can learn this. Kq upon 2r cube, 3r square minus small r square. Or if you put r is equals to 0, which is at the center, so V at center will become, this r will become 0. So only 3r square will be there. R square will be cancelled, 2 power of r cube. So it will be 3 by 2 times kq upon r. And this is nothing but kq upon r is the potential of surface. So at center, it will become 1.5 times of surface. Okay. So this is also a relation. You will remember it. Got it? Now, electric potential due to electric dipole. So this is a very simple thing. Okay. You have a dipole, same arrangement, minus q plus q, and this is the center point. The length, the distance between them is, we will take 2l. Okay. So if the point, two cases will be here. If, or you will say at axial position. Axial position. Okay. So here is the point P, let's say, and you need to find out the potential. So V at this P, what should be? Potential by this charge plus potential by this charge. So potential by this charge will be, and let's say this distance is R. So what about this distance? This is L. So it is R minus L, and it is R plus, for this point charge, this is R plus L. So Vp4 minus Q, let's say V1. V1 is KQ upon the distance, which is R minus L. V2 is KQ upon R plus L. So V is equals to V1 plus V2. Just a second. V1 plus V2. So V1 here is KQ upon R minus L plus KQ upon R plus L. Now you take KQ as common. So it will become R plus L, plus R minus L. Now, you guys have not noticed that I have made a mistake knowingly. And what is that? I have not put the sign of the charge. So in the expression of potential, you need to put the sign of charge. Okay. If this is minus Q, so it will be minus KQ upon it. So this expression would become minus of R plus of L divided by R square minus L square. R and R will cancel out. It will become 2L. We know that dipole moment is Q into 2L. And this will become KQ into 2L. So we will write it as V at P will become KP divided by R square minus L square. And if the dipole is very short, which means R is greater than L, so you will negate this L square. So Vp will become Kp over R square. The electric field will be Kp over R cube, and Vp will be Kp upon R square. Got it? For perpendicular position or equatorial position. For equatorial position, the potential will be 0. because you will understand it here. Here is the dipole. Here is the dipole. You will take this perpendicular bisector. So potential for this will be the distance between this point and minus q, and this distance will also be same. To the same distance, opposite charge, the potential will be 0. Okay. So this is it from my side for today. Thank you so much for being attentive. Okay. Rest of the thing we will discuss in the next lecture. Till now, if you have any kind of doubt, you can ask. Otherwise, the lecture is being over. And try to be attentive. This is for you guys. Okay. Got it? So thank you so much. Take care of yourself. Any kind of doubt you can ask. Otherwise, you can leave. Thank you so much. Thank you, Sangeeta.